Hello ladies and gentlemen, welcome back to math. Today we're going to continue working on those polar coordinates. So far we've done multiplication, division, squares. Today we're going to do roots. Okay? So we're still dealing with those r coordinates and cosine and sine. Okay? Our objective for today is to find all the answers for the polar equation. Okay? Meaning, when you have squares, okay, or radicals, should I say, a radical, the outside always has the number, okay? Either you're looking for pairs of twos, pairs of threes, so on and so on, okay? Today's equation, okay, is n radical of r, okay, cosine, parentheses cosine, of theta plus 2 pi times k over n plus I sine of the same, because remember, always cosine and sine are the same. If not, then the equation doesn't work. It has to be the same. So theta plus 2 pi times k over n. Meaning, n is always whatever you're looking for. Okay, if it's asking you to look for the square, then n is 2. If it's looking for cube, then n is 3. If you're looking for pairs of 4, then n is 4. Okay, k on the other hand, because there's a k in here, okay, is whatever is left over of the equation of n minus 1. Okay, so k equals n minus 1. Okay, you might ask yourself, what do you mean? You're going to see it in action in a minute, okay? N is whatever you're looking for. Whatever square, cube, or so on, okay? Meaning, our example for today, obviously I'm going to do 2 examples, okay? The first one is, we have C equals 4 cosine of 90 degrees plus I sine of 90 degrees, okay? And it's asking us to find the square, okay? The square root of our radius, okay? So therefore, if we're looking for square roots, n equals 2. For k, since 2 equals n minus 1 equals 2 minus 1 is 1, that means that k equals 0 and 1, okay? It can be either one, meaning, the way we're going to break down this equation is, we already know that we're looking for squares. That means we're looking for a 2 as your n. So in the n here, we're going to put a 2. Okay. Our k is 2 minus 1, which n is 2. 2 minus 1 is 1. Therefore, whenever you count, it's 0 and 1 are your numbers for k. Always start with 0. Okay. So it can be 0 or 1. If the 2 was a 3, then 3 minus 1 would have been 2. That means that the numbers you're looking for are 0, 1, and 2. Okay? So the bigger the number is, the more possibilities you have. Okay? Which means we have to solve for more numbers. Here we're only solving for 2, because we only have 2 possibilities. So our problem is, we have one problem where k equals 0, okay? So we have 2, because 2 is our n, okay? Our r, which in this case is 4, cosine of theta, which theta is 90, plus 2 pi times 0, because k is 0, that's what we're using for k right now. over our n, which our n was 2, plus I sine, again the same thing, 90 plus 2 pi times 0 over 2. Okay? So if we're looking for groups of 2's, 2 times 2 gives you 4. There's 2 2's. Okay? 2 and 2, therefore there's a group. Since we're looking for pairs of 2's, we only have 1, which in this case becomes 2. Cosine. Remember, pandas, okay? You cannot combine 90 plus 2 pi because 0 is being multiplied to 2 pi. So 2 pi times 0 is 0, right? So we're left with just 90 plus 0, which is 90, over 2, plus I sine, again, 90 over 2, because it has to be the same, plus, again, 2 pi times 0 is 0. So we have 2 cosine of 90 divided by 2 is 45, plus I sine of 45. So cosine and sine at 45, if we look at the unit circle, okay? Technically by now we should already know all the radians in sine and cosine. If you guys remember, for cosine for 45, we have pi, or radius over 2, okay? Radius of 2 over 2, plus I sine our radius of 2 over 2, and then our 2 on the outside, which technically we don't really need the sine. So 2 can go into both of these numbers. So it becomes 2 radical of 2 over 2 plus 2 radical of 2 over 2i. Okay? Which 2 can go into 2 one time. So we're just left with radical of 2 plus radical of 2i. Because the 2's cancel out. And that is our answer. But wait, that is only one answer. Okay? For k equals 0. Now we have to do the same thing, the whole process again, but this time we're going to use 1. Okay? So let's use another color here. Make sure you have all the notes. Okay? Technically everything from here on down, it's pretty much the same thing we've been covering. The only difference is the beginning, how to set it up. Okay? So we already solved for 1, now we're going to solve for the other one. This time we're going to use k equals 1. So again, since we already know what the square root of 4 is 2. I'm going to skip a step here. 2 cosine of 90, which is the original, plus 2 pi times 1 over 2, okay, plus I sine of 90 plus 2 pi times 1 over 2, okay. Again, we keep the 2 on the outside. We have cosine of 90 times 2 pi times 1 is just 2 pi. But instead of writing 2 pi, we can turn it into degrees since we're already dealing with degrees here. Okay? If you guys remember on the unit circle, 2 pi is a specific number. Okay? Which is 360 divided by 2 plus I sine of 90 plus 360 over 2. Okay? Since we're not doing anything to the outside yet, we have 2 cosine 90 plus 360. Okay? That's 450 divided by 2. So 450 divided by 2 plus I sine of 450 divided by 2. So 2 cosine of 450 divided by 2 is, half of it is 225, plus I sine of 225. On the unit circle, 225 is what? Do you guys remember? 225 is negative radical of 2 over 2 minus radical of 2 over 2i, which again, if you guys remember, technically this works out the same as the other one. 2 can go into both numbers. We're going to have negative of 2 radical of 2 over 2 minus 2 radical of 2 over 2, which technically the 2's cancel out, so we're left with negative radical of 2 minus radical of 2i. Okay? And that is our answer. So we had to find two answers, okay? Again, the bigger the number is for k, the more answers we have to find, okay? All right. So here's your assignment for today's, guys, okay? Make sure you have it down. We have 16 cosine of 90 degrees plus I sine of 90 degrees. Okay, we're looking for, well, let's do this. We're looking for square root of 2. Okay, so 2. And then there's one more. We're looking for a cube root, okay, of 64 with cosine of 30 degrees plus I sine of 30 degrees. Okay. Alright, guys, make sure you submit your answers as soon as you're done watching the video. Again, we're looking for square root, and then we're looking for cube root. That determines your n. Okay, you have to find your k, and then you have to solve for how many k's it gives you. You can start it at 0. Alright, guys, make sure you submit your answers. If you have any questions, let me know. But as soon as you're done watching the video, make sure to submit your notes and your answers for today's work. And I'll be here waiting for your email.